All right, everyone, this is your last part of your practice test. This is the graphing portion. So for this one, you had a population of rabbits over 15 years, and you had to plot the number of rabbits over the course of those 15 years. So the first thing I want to do is I want you just to look at your graph. So don't worry about the exponential or the logistic part now. Let's just look at your graph, and I want to make sure you have all of the parts of the graph that you need to have full credit. Okay, are you ready? So look at your graph, have it next to your iPad, maybe have a highlighter or a marker or a pen or something in your hand. Okay, so the first thing is I want you to check that you have a title. Your title would be worth 1 point. In the title, you need to have the word rabbits and you need to have the word years, and then it should make sense in a sentence. So double check your title now. That's 1 point. If you forget one of those words, that's a half point off. Okay, on your x-axis, you should have the word years written, and you should have gone by ones, just like I did. If you happen to put years over here, that would have been 1 point off because time, years, always goes on the x-axis. This is the x-axis. All right, on the y-axis, you should have number of rabbits. Now, we needed to go to 59. So I chose to go by threes and get all the way up to 60. Okay, I did that by just taking 59 divided by the number of boxes I have, which are 20. 59 divided by 20, and then I rounded up. I got like 2.8 something, and then I rounded up to 3, and that's how I knew to go by threes. If you went by, let's say, fours, probably was okay. If you went by fives and you went all the way up to 100, I might ask you that if you scaled it too high. Okay, so really 3 is the perfect number, 4 is okay. If you did anything more, 5 or more, then you probably need to scale it less next time. Okay, so those are just the basic graph requirements. So that's 5 points right there that you did all of those things. Then if you drew dots and connected the dots and made a line graph, that would be your 6th point. Okay, so that's what you're looking for in your graph. All right, now let's go up to the question. So this was actually a tricky one. When I was drawing the line graph out, I actually wondered to myself, is this exponential or logistic? Because it kind of takes a J pattern. It goes up straight up until right about here, and then it kind of leveled off a little bit. So I actually kind of asked the other biology teachers, like, what do you guys think this is? So if you were confused, if you're like, oh my gosh, this wasn't super obvious, that's okay, because this one was a tricky one. So I actually think that because it kind of maintains, look at the end, the last 4 years, see how it kind of levels off there? So I actually called it logistic in the beginning. And I said, yes, there was a carrying capacity. Carrying capacity would be the number it levels off at. It doesn't have to be an exact number. So it doesn't have to be like 59, 59, 59, 59, 50, I mean, so that's how I answered it. If you put exponential for this, it was a tricky one. So what I wanted to do then is, because this one was a little tricky. Oh, I'm sorry. Let me go over number 3 first. It says draw a dashed line on the rabbit graph. What would happen if a predator moved in at year 10? So there's my dashed line at year 10. So what I did is I showed the population leveling off, because if they have a predator, that's a limiting factor. They can't grow exponentially anymore. So that's why I drew my line kind of leveling off. If you drew your line more like down and then leveling off, that's fine too. Okay, but it definitely wouldn't go straight up anymore. Definitely not that. Okay. All right, so now what I want to do is, just because this one was kind of in between, and I don't want you to be confused on your test tomorrow or the next day, I want you to see 2 other examples. And you can see I changed the population a little bit. And all I want to do is just look at the graph with you and make sure you can identify this one. So here's my new graph of my rabbit population. So take a look at it. Would you say this one is exponential or logistic? Okay, hopefully you said exponential. This was a very clear exponential graph. It goes straight up. Notice it's not, I didn't want to erase that. Notice it's not stopping anytime soon. Okay, is there a carrying capacity? No, because exponential growing populations do not have a carrying capacity. They have no limiting factors. They have unlimited resources and they are just growing like crazy. Okay, all right. And then the last one I want to show you, I changed the rabbit graph to make it the rabbit population, just to make it more logistic so you could see what that would look like in a more clear, obvious example, like that would be on your test. So here we go. Here's my graph, and you can see right here, the rabbit population kind of just stays where it's at, right? For at least 5 years. So that would be a pretty obvious logistically growing population. They stopped growing and they're maintaining that number for definitely a few years. So then the next question, since it's logistic, does it have a carrying capacity? Yes, it does. It would be 57 rabbits. That's where it starts or stops growing right there. Okay. All right. Now, if you need more help with this, so if you didn't do so hot on this, the in-class kick, I would recommend that you relook at the rabbit fruit fly activity. Okay, as I think that would be a great thing to look through. Look at your wrong answers, correct your wrong answers, look at your graphs, see what you did wrong on your graphs. The rabbit fruit fly activity and this is very similar to your graphing test tomorrow. Okay, all right. Hope